This is the homework helper for Chapter 3, Section 4 in the 8th grade workbook entitled Functions. All right, let's go ahead and take a look at the first couple questions here. 1 and 2 are asking me to complete the table and graph each function. So we're going to use the same approach in each of these. I'm going to go ahead and work through question number 1 with you. Notice what they've given you. There is a function, and in the table there they've suggested various x values. What you're going to do is plug those numbers in for x, figure out what that then equals, and then that will be the y value, and then you'll pair the x and the y values together to write a coordinate and graph said coordinates on the coordinate plane there. So where we've got negative 2x plus 5, I'm going to change x into each one of these numbers. So in the first one there, since they wanted me to use negative 2, that's going to be negative 2 times negative 2 plus 5. The next one down with negative 1 is going to be negative 2 times negative 1 plus 5. The next one with 0 is going to be negative 2 times 0 plus 5. This one here with 1 is going to be negative 2 times 1 plus 5. And finally with 2, negative 2 times 2 plus 5. All right, so now we're solving each one of those, and of course, shouldn't need to be said, but I'll say it anyway. You want to make sure you use order of operations here. So you're going to do those multiplications first before you go back and do the adding. So in the first one here, negative 2 times negative 2 is going to make positive 4, plus the 5 is going to make 9. In the second one, negative 2 times negative 1, that's going to make positive 2, plus 5 is going to make 7. In this third one, negative 2 times 0, that's going to give me 0. And then I'm going to add 5, and that's going to make 5. Now, take a look at the y column before we keep going here. Do you see a pattern? Do you see that as we're going down, it's just subtracting 2 each time? Let's see if that continues. The next one, negative 2 times 1 is negative 2 plus 5 is 3. Yep, the pattern seems to be holding. Last one, negative 2 times 2 is negative 4, plus 5 is 1. All right, so again, my x and y now combined make my coordinate. So this is negative 2, 9 from the first one, and negative 1, 7 from the second one, and 0, 5 from the third one, and 1, 3 from the fourth one, and then 2, 1 from the last one. And that's what I'm going to go ahead and graph on my coordinate grid there. Remember, the first number is an x value. The x-axis is the one that runs left to right. And the second number is a y value, and that's the one that goes up, down. Now, as you can see, they're only giving us the top of the coordinate grid here, and you can see why they did that is because down here we would have negative y values, but if we look at our y values, there are no negatives, so we don't really need that portion of the graph. It doesn't affect anything we're going to do here. So the first one, negative 2, 9, so from the origin, I'm going to go left to negative 2, and then all the way up to 9, which is quite a ways up. Negative 1, 7 is my next one. So from the origin, I'm going to go left to negative 1, and then I'm going to go up to 7 and put a marker there. 0, 5. Well, since the first number is 0, I'm not going right or left there. Remember, that first number is always this x-axis, the one that goes left to right. And the second number being 5, that means I'm going up to 5. 1, 3. Well, that means from the origin, I'm going to go right 1 and up 3 and put a dot. And finally, 2, 1. So from the origin, I go right to 2 and up to 1 and put a marker. And since we're graphing these, obviously we want to connect our markers. Now, as you can see, I've made X's on mine just so you can see them on the presentation. Hopefully you've made dots. That would make a lot more sense. But then we're going to connect these guys as nicely as we can. And we have the graph of a line. And again, you'll do the same thing in number 2. I'm going to tell you right now, it's also the graph of a line, so you should see some type of pattern there. You might not necessarily be subtracting 2 as we go down the list. And you'll also see the same thing when we make the graph, in that if you have a series of dots that are lined up and then all of a sudden one goes way off by itself, you probably did something wrong there, because there's going to be some type of pattern that's evident there. All right, if you're getting some other shape, a V shape, a U shape, a T shape, an S shape, something is not correct. In number 2, that is, again, because number 2 is going to end up being a line as well. All right, let's go ahead and go down to the bottom here. In 3, 4, 5, and 6, the question or approach to these things is the same. because we're in each trying to figure out if the relation represents a function. So there's a couple ways we can figure out if something is a function. If it's a graph, we can use that vertical line test that we saw in the instruction today. If it's a table, we're probably going to be looking for x's. If an x repeats, then it's no longer going to be a function because you're double assigning a value there, and a line type of function that we've seen in the earlier question there, it's never going to go back across an x value. It could go across a y value twice, absolutely. Y's can repeat in those tables, but x's cannot. If the x repeats, it's not going to be a function. And then if we have an equation like we do in number 3 there, which is where we'll start, well, you're going to make one or the other, or perhaps both, to figure out what's going to happen there. So we've got y equals 1/3 x minus 2/5. And we're supposed to figure out if that's a function. So you can make yourselves a little table there and plug in some x values and figure out what the y values would be. That would be a good place to start. Now, because I'm multiplying by 1/3, not that I couldn't, but I really don't want to pick numbers like 1 and 2 and 4. The reason being is because if I'm going to multiply by 1/3, it's much easier if I pick multiples of 3, like 3 and 6 to work with there, because that's going to make that first fraction disappear anyway and probably make my life a whole lot easier. So I'm going to pick some x values here, but again, they're going to be multiples of 3. And if you're not understanding that, you'll see exactly what I just said in a minute here. I'm going to pick -6, -3, 0, 3, and 6. Now let's get the easy one out of the way first. If I choose to start with 0 here, multiplying by 0 is going to make this disappear. Again, remember order of operations, so I'm putting my hands on this multiplication first. And then if I subtract 2/5, that's -2/5. Or if you want that as a decimal perhaps, that's going to be -0.4. All right, let's go to 3 here. Again, let's see what I was just talking about there. If I take 3 and multiply it by 1/3, well, 1/3 of 3 is 1. And that's nice because now all of a sudden the fraction disappeared. And you're saying, why is that great? Well, look, this other thing is a fraction. If I had two fractions with different denominators, hello, common denominators. I don't want to do that work. But since I picked 3 and I multiplied that by 1/3 and I got 1, now I'm just doing 1 minus 2/5. I don't have to really worry about common denominators. I don't even really have to think about it here. All right, 1, or if you want to think of it as 5/5 minus 2/5, that's going to give me 3/5, or if you want that as a decimal, 0.6. All right, let's go ahead and take a look at 6. 6 times 1/3, well, again, something nice is going to happen there. Think about it. 6 times 1 is 6, divided by 3 is going to give me 2. And then I'm going to subtract 2/5. Well, if you want to think of it another way, something with 5 as the denominator, if that really helps you, instead of 2, that would be 10/5. And if I take away 2/5, I'm going to have 8/5 here. And if you want that as a decimal, that's going to be 1.6. Now, take a look at my y values here when I'm writing them as fractions. Look at the numbers I picked and what's happening here. To go from -2/5 to 3/5, what did we add in the numerator? We added 5. What did we go when we did 3/5 to 8/5 in the numerator? We added 5. So if I'm adding 5 going this way, I'm probably subtracting 5 going this way. Good guess. Let's try it. -3. 1/3 of -3. Well, that's going to make -1 or -3/3 if you want to think of it that way. All right, and then I'm going to subtract the 2/5 here. Well, if I have -3/3 or -1 happening here, all right, that's -5/5 if you want to go common denominators, and then we subtract 2/5, like it says, that's -7/5. Well, look, exactly what I said was going to happen. It subtracted 5 going this way. So instead of working for it, let's just do what we think is going to happen here because we're right. This is -12/5 in this last spot here. And again, we can go ahead and change these to decimals if you really want to. Again, it's not really necessary, but this is going to be negative 1.4. And this one here, that's going to be negative 2.4. Okay, so do we see any x's repeating here? No, we don't see any x's repeating here. But that would be a good indicator that this is a function. But if you need some more assurance of yourself, make yourself a little bit of a graph here. If we can do that, it's not going to be a pretty graph with all those decimals, but we can handle it. 1.6 means I go right 6 and up 1.6 spaces. Well, at least that's easy. It's not a lot of jumps. 3.6 means I'm going to go right 3 and up 0.6. 0, negative 0.4 means I'm not going to go right or left. I'm just going to go down 0.4. And you can kind of see what's happening here. If I just connected these, we could keep going if we need to. But I think you can see this is a line. Well, we know from up top, lines are functions. But remember, the way to tell based on the graph is to do the vertical line test. The vertical line test says draw a bunch of lines through your thing. Each one should cross over your graph once and only once, never more, never less. Well, each one does cross one time. So yes, on a whole bunch of different ways, we proved that number 3 is a function. In 4 and 5, you're going to look at the table, and again, because they're tables, you're going to look for repeating x's. If you have repeating x's, it's out. If no x's repeat, it's all good. In number 6, where you've got the graph there, you're going to use the vertical line test just like we did when we graphed 3, and as long as it passes, it's a function, but if it doesn't, it's not a function.